Here in this case, now for this problem I will not mention the steps because now you are aware of. Is it right? The steps. You are aware of the steps. That's why I will not write the steps. Just I will use the calculations directly. Is it right? What is the first step? Remove the load resistance and redraw the same circuit. I will write here. Removing load resistance and redrawing the same circuit. We get. Now what we get here? I will draw the same circuit here. In this case, its circuit will be something like this. Just we are removing the load resistance, nothing else. And we are redrawing the same circuit. We are redrawing the same circuit as it is. Here is the A terminal, this is B terminal. This is minus plus, its voltage is 2 volt. This is 4 ohm. This is 5 volt. This is 4 ohm again. Here is 8 ohm. This is 6 ohm. And it is the 20 ohm. This is plus minus. This is plus and minus. This is minus plus, already it is marked. Now here, we have applied the step number 1. But here I have not written the steps. And we will not write the steps further onwards. So here in this case, now we are interested in the calculation of the VTH. Now look at carefully. The voltage between these 2 points, when the load resistance is removed, the voltage between the terminals is the VTH. Is it right? Now we will try to find out the voltage from B towards A. This voltage plus this plus this plus this plus this value will be the value of the VTH. We have to calculate current in this branch, which is 0. We have to calculate current in this branch, which is also 0. Is it right? But we have to calculate current in this vertical branch. For that purpose, we will assume this is as a loop, and because it is only one closed loop, we will assume its current as I. We will mark its polarities. This is positive terminal of the battery, negative terminal of the battery. This is positive, this is negative terminal. Now, depending on the assumed direction of the current, we will mark the polarities. It is a plus, this is minus, plus, minus, this is plus and minus. Now, we will apply the KVL to this figure. The polarities are having lot more importance in case of the Thevenin's theorem. You will understand in this problem. This problem में समझ में आ जाए. So here, if we are traveling from this point, we are traveling in the clockwise direction. Negative to positive plus, its voltage is 20. Then positive to negative minus, 8 into I is its potential. Then positive to negative it is a minus, 4 into I is its current or potential across this. Then positive to negative is minus 5. Then positive to negative, that is minus 6 into I, which is equal to 0. This is the application of the KVL. Now find out this value. I will shift these items on the next side. This is plus 20 and minus 5, it will be plus 50, which is equal to this 8 plus 4I, 12, and 12 plus 5, 15, 17, I guess. This is 17I. This is right. Now here in this case, now this I is equal to 15 divided by 17. 15 divided by 17. Find out its value. How much is the value of this current I? Yes, anyone? Yes, Saurabh.
88.
Sorry?
0.88.
0.88 amperes is the value of its current, which is I. If we know the value of its current I, then we can find out its value of the VTH, that is Thevenin's equivalent voltage. Now look at here, this VTH is equal to, how is this value? We are traveling from the B towards A. Voltage across this resistance is 0. It is modulus value. I am traveling in this direction. This value is 0. Then we are traveling upwards, negative to positive, which is a plus. How much is this voltage? 5. The negative to positive, that is a plus. How much is this voltage across 4 ohm resistance? 4 into its current, and its current is 0.88. Then we are traveling back. This is 3 ohm. How much is the voltage across this 3 ohm? Which is again 0. Then we will travel further, that is negative to positive, which is a plus. Which is plus. How much is the voltage across this battery? It is 2 volt. Is it right? This is 2 volt. And in this case, we will try to find out its value. We will try to find out its value. Now here in this case, current in this branch is 0. Still, the voltage of this source is the 2 volt. That you have to remember. And agar ye battery ulta hota, in that case, this potential will be positive to negative minus, and this will be negative to positive, that will be the plus. Because this polarity depends on the current, and this polarity depends on the battery terminals. Now simplify this value and find out its value of the VTH. Yes.
सर हमारा उधर गलत हुआ, वो 17 नहीं आएगा, 18 आएगा. 15 डिवाइडेड.
Sorry, ये 89.
Yes sir.
Just I will check. This is value 4 plus 8. How much? Sorry. 4 plus 8 plus 6. It is 18. Absolutely correct. This is 18. Correct. And how much is this value?
0.83.
This is 0.83 amperes. Bilkul sahi. Correct. In that case, this value will be 0.83 amperes. Fine. How much is the VTH?
10.32 volt.
10.32 volt is the value of VTH. I will come back to you. 10.32 volt. Yeah.
Yes
sir. Akshay Bahekar. बड़ा स्क्रीन मिनिमाइज करतोस तू सारखा सारखा. अक्षय, you are minimizing the screen. I am able to see your screen. You should not minimize the screen. Akshay Bahekar. या और किसके पास आंसर है? शैलेश, रुचिरा, रोहन, ऋषिकेश, अविनाश, आकाश. Anyone? Check these answers. Yes, Akash. Correct answer. Check it out.
Correct. 10.32.
Okay, yes. Now here in this case, if we know the value of VTH, the next is we will calculate the RTH. I will write the same. For calculation of RTH, we remove RL and all sources are replaced by respective internal resistances. And we will draw the figure. Now I will draw the figure for calculation of RTH. This figure I will take reference. Source will be removed, means its figure will be something like this. This is the figure A, this is B. It is 3 ohm, this is 4 ohm, this is 4 ohm, it is 8 ohm, and this is 6 ohm. This is the figure for the calculation of RTH. What is the next figure? In this case, these two are in series combination. This next figure will be something like this is the A and this is B. This is 3 ohm, this is 4 ohm, this is 4 ohm, and its value of this series combination will be 14. That's right. Next, these two resistances will be in parallel combination, which can be replaced by the single resistance. There is A terminal, this is B, it is 3 ohm, and its value is 4 ohm. How much is this parallel combination?
$3.11.
3.11 ohm. All of you should be with the calculator. मुझे बहुत सारे लोग आज calculator के साथ नहीं दिख रहे. Is it right? From the next lecture onwards, everyone should have the calculator with you, and everyone should participate in the calculation. Now this RTH is equal to 3 plus 3.11 plus 4. How much? Because all these three are in series. How much is the RTH?
10.11.
10.11 ohm is the value of RTH. Now, finally, if we know VTH and RTH, then complicated network is replaced by Thevenin's equivalent network. How will be the figure? This will be the last figure for this problem. And reconnect the load resistance which is removed in the first step. This is A point, this is B point. The load resistance which we have removed is this 10. I'm reconnecting it. RTH, this is 10.11 ohm, and this is VTH which is 10.32. This is 10.32 volt with plus and minus. Now this IL is equal to, no need to put the formula, directly you can put the values. It is 10 divided by this 10 point, this is 10.11 plus 10, which is equal to, how much is the load current? That is 10 divided by, it is 20.11. How much is IL?
Point 32 नहीं देने.
Point
32 आंसर नहीं सर, ऊपर का 10 लिया है सिर्फ, आगे के पॉइंट.
Sorry, 10.32. 10.32. Yes, it is 10.32. Fine.
51.
What is the final answer?
0.51.
0.521 amperes. Is it right? 0.521 amperes. 51. 0.51 amperes. This is 0.51 amperes is the current flowing through the load resistance. And this is by using this theorem. That is Thevenin's theorem.